Hi guys, my name is Nakul Shah and I would like to welcome all of you all on behalf of Edureka to this blockchain webinar. Before we get started with today's webinar, I just want to put your attention to this meetup group that Edureka has. If y'all are not already a part of this Edureka meetup group, then please join it today. And through this meetup group, you all will get access to 150 plus webinars every month, which are available on various topics, various courses. It's a really useful resource that y'all can cash in on, and it would be great to get your career a boost and get acquainted with new technologies. So if you all haven't joined this meetup group as yet, please do log on to meetup.com and you all can search for the Edureka Masterclass group and be a part of that group. Now, today we'll be looking at the blockchain webinar. Now, before I get started with today's webinar and the coursework, let me give a brief introduction about myself. My name is Nakul Shah, and I am the director and founder of Set Development, which is one of the leading blockchain technology companies in India. We've been awarded as the top 5 blockchain companies consistently in the past 2 years. And I myself started my career in Boston at a major financial institution. That institution was also one of the first ones to start looking into blockchain as a technology. From there, I moved on to another fintech company. And during the second year of my tenure with that company, I had started learning a lot about blockchain as a technology. A lot of our a lot of people within my network had started talking about this new technology, this new paradigm, and that's how I got introduced to this entire space. Then I migrated back to India, started my own company here, and since the past 4 to 5 years, I've been working dedicatedly towards this technology. I have also authored a book on blockchain. The book is titled Blockchain for Business with Hyperledger Fabric, which is a good enterprise overview of how blockchain can be used for various use cases, various enterprise solutions can be developed on this technology. And the book is easily available on various platforms like Amazon. So you can always take a look at that. And I'm glad to be affiliated with Edureka in taking a number of their courses. And I'm happy to be a part of today's webinar. So let's get started with today's webinar now. Blockchain has been the latest buzzword trending in the internet for the past 2 to 3 years, both blockchain and Bitcoin, in fact. And though Bitcoin is great, it has shown a lot of potential, but there are certain aspects of Bitcoin which are questionable, because of which it has been in gray area for quite some time. But whether Bitcoin stays or goes, the underlying technology which makes Bitcoin possible, which is termed as blockchain, certainly has proven itself to show immense potential, immense applicability, and something that started as an evolution is soon going to cause a big revolution in the technology space. If you look at investors in the past couple of years, they have been cashing in huge amount because they really feel that there is a huge potential in this technology. They understand the fortune of this ingenious paradigm shift, and they are quite bullish in regards to the entire ecosystem that blockchain can bring about. Even if you look at industry experts and tech enthusiasts, they're coming up with blockchain-based products, blockchain-based solutions every other day. So it's the perfect time to be a part of this revolution. If you're planning to start your blockchain career, now is the right time to dive in when the technology is in its nascent stage and the industry is really expecting a lot of big things to be developed in and around this platform. So today's session will give you a complete idea, a brief idea with respect to blockchain and Bitcoin and what this technology is. We'll be briefly discussing the various aspects associated with this technology and how this technology is looking to revolutionize the entire internet age. So without wasting any time, let's move forward and let's start taking a look at today's session. Now, blockchain is being used highly for transaction management, and it is replacing the current existing transaction management systems across various organizations, not just financial, but a lot of other industry sectors are being disrupted by this technology. And if a technology is replacing the existing systems, then there certainly must be problems and shortcomings, and that's exactly what we'll be discussing at first in today's session. Once we've understood this, we'll try to discuss how cryptocurrencies can help solve a lot of these issues, or rather, blockchain can help solve a lot of these issues, as well as how these transactions take place. Now, if a transaction has to take place, there certainly needs to be a medium for that transaction, and that's exactly where blockchain comes into the picture. Now, moving on from there, we will talk about the various concepts around blockchain, the various features of blockchain, as well as we'll see where blockchain is being used apart from the banking domain. So those are a few things that we'll be covering today. Of course, before I start, I do want to point out to you all that during today's session, we'll be making a number of references to concepts like Bitcoin and cryptocurrencies, Ethereum, etc. And these terminologies, they are important in order to understand the overall operation of blockchain. But at no place are we trying to promote any kind of activities associated with cryptocurrency, like mining, trading, etc., which in a lot of jurisdictions has been restricted. So we do not intend to promote any such activities, and this session is strictly from an educational perspective, and our focus is primarily on the technology aspect of the same. So I expect the session to be received in the same manner. So let's get started. Now, for the first part, what we'll be doing is we'll take a look at the various issues associated with blockchain with regards to the banking system. Then we'll review how Bitcoins, how they solve all these issues, and what are basically Bitcoin transactions. So how these transactions take place, how these transactions are executed. And then we'll understand how blockchain is put into the entire equation. What role does blockchain play in this entire ecosystem? The difference between Bitcoin and blockchain, because a lot of times we've noticed that people use the terms Bitcoin and blockchain interchangeably, and that is not accurate. So Bitcoin is just one application which has been built on blockchain, and blockchain as an underlying technology is capable of doing much more. Just because Bitcoin is in the gray area, just because there are restrictions around Bitcoin, doesn't undermine the overall potential of blockchain as a technology. And that's what we try to understand, how blockchain is different from Bitcoin. Then we'll take a look at the various concepts around blockchain, what blockchain comprises of, what are the key features around blockchain, and also take a look at a few of the use cases of blockchain in various industry sectors, not just banking, but government, voting, healthcare, etc. And finally, we'll take a look at a banking related use case, leveraging blockchain as a technology. So that's what we will be reviewing today. Also, towards the end, we'll go through one of the blockchain platforms, the various steps involved in utilization of that blockchain platform, which is called as Ethereum. So even though the initial part of our session today is going to have a higher focus on the Bitcoin blockchain system, but towards the end, we'll also review the Ethereum blockchain. Ethereum is the second largest blockchain platform by market cap, and it is one of the most revolutionary blockchain platforms created. It's the advent of Ethereum and similar platforms which actually made blockchain usable for various different kind of applications apart from simple financial transactions or cryptocurrency transactions. So we'll go through some of the basic steps involved in utilization of Ethereum blockchain, right from installation of Go Ethereum, which is the the open source code of Ethereum, registering an account on the Ethereum blockchain, creation of private version of that blockchain, understanding what is the difference between public and private blockchains, and finally how these transactions are executed, how these transactions are performed. So those are going to be a few of the things that we'll be discussing today. Now, at any point, if you'll have any questions, if you'll have any doubts, if you'll have any queries, feel free to use the questions tab that we have and put in your queries over there. As and when we move forward, I'll keep picking up questions from there and I'll be answering them. If at any point I feel that a certain question is not directly related to what we are working on today, or if it's going to be covered later on in the slide deck, then I'll put that question in the parking lot and I'll pick it up at a later time. So let's get started. Now, I think there is a question over here. So let me see. All right, so let's get started. I hope everyone is able to hear me well. Everyone is able to see my screen at all times. Guys, are you able to hear me well and see my screen? All right, so most of y'all have said that y'all are able to hear me and see the screen. So I think we are good to go. In case y'all face any issues with viewing my screen or with listening to me, please try and log out and log back in and just try clearing the cache and cookies on your computer. So that should help you resolve this issue. All right, guys, so let's get started. Now, issues with the current banking system. So as I said, if blockchain is replacing some of the existing systems, if it's being used for some of the existing systems, then there have to be certain issues associated with that. And one of the systems that blockchain has been disrupting is the banking system. So what are some of the issues that the banking system faces? Now, before I go ahead with the slides, can some of you all tell me, take a moment and tell me what do you feel is the issue with the current banking system? This can be something that you feel is wrong with the current system, or something that is inconvenient pertaining to the current system. So anyone, any kind of issues that you feel you're facing with the current banking system? Anyone, guys? Okay, so Sai has pointed out a very good point. He said that service charges are a big menace with the current banking system. You're absolutely right, Sai. Now, service charges or transaction fees are certainly an issue, a major issue associated with any banking system. Any other issues that any of y'all must have faced or y'all feel is a disappointment given the current banking system? Okay, so let's move forward and begin with the first issue that Sai has correctly pointed out. It's the transaction fees or the service charges that the bank takes. And now let's take this simple example here. So here we have two people. We have Chandler on the left and Joey on the right. And Chandler wants to send $100 to Joey, but due to the transaction fees that the banks charge, Joey ends up getting only $98. Now, it may not seem a very huge amount, but let's assume that every day there are 10,000 such transactions that happen. And in that 10,000 transactions, even if it's a 2% commission, it's a huge amount that we are talking about over here. In fact, if you look at what is given here on the slide deck, in the year 2015, three organizations, that is, three of the major organizations globally, they have made close to $6 billion just from ATM and overdraft transaction fees. So this is a very huge amount of money, and most banking and financial organizations, in fact, depend on these kind of fees to have their source of income as well as their profits. In fact, in I think 2016 or 2017, I had read a certain report which said that every year the global transaction fee for remittances, just cross-border remittance related transaction fees charged by the banks globally is north of $20 billion. That's how huge these fees are. Now, wouldn't we all like not to have to pay these kind of transaction fees? Or even if we do have to pay these fees, then preferably it's much smaller than what they are currently charging today. In fact, everything these days, it comes with a certain amount of fixed transaction fee. Even though it would be a small amount, we would be happy to reduce that amount even further, or not to have to pay those kind of fees at all. So moving forward, let's talk about the next problem that is with the current banking system. So this is the first problem associated with the transaction fee. Now, the second problem associated with the transaction fee is called the problem of double spending. Now, this is another major challenge that you might have seen within the banking system. So if you're not from a if you are from a financial industry, then you might be aware that basically the way the system works is that, let's say Peter has $500. Now he wants to make a payment to James and a payment to Mary. Now, what Peter does is that when he has $500, and if he has to pay $400 to James and $500 to Mary, then he can make only one transaction. He can spend the money at only one place, because otherwise he won't have enough balance available for the other. Now, if Peter makes two transactions simultaneously, one of $400 to James and the other of $500 to Mary, then this kind of a transaction is a major problem for the banking institution, because at the onset, both transactions within their own silos or within their own respect might seem legitimate, because the overall balance that Peter's account has is $500. But when you put all these both these transactions in perspective, that is when you realize that these transactions, they are not actually legitimate transactions, because overall, even though Peter has just $500, he's trying to spend $900 in the form of transactions. And this is one challenge that most banks or financial institutions had faced when they were working with online payment systems. Apart from this, also the challenge of financial crisis and financial depression was another major issue for the banking system. So if you look at the banking system, the way the banks work is based on trust. So their entire business model is based on trust, because I cannot trust to keep my money with some stranger, and I do not want to keep all my money at home. That's why I would go to a bank, deposit my money out there, and I would hope that the bank would keep my money safe and return it back to me when I ask for it, or they will send it to whoever I instruct them to. Now, in 2008, 2009, when the entire global recession started, a number of banks and financial institutions went out of business. And that is when people started realizing that they needed a system which was independent of intermediaries or third parties. So a system where they can have complete control over their own money or over their own value, and they can transfer this value or money without requiring any intermediary or third party, or without someone else brokering these kind of transactions. And that is when Bitcoin actually came to the market. That is where, like in 2008, Bitcoin hit the market, and it gave people a way in which they could transact money without requiring these kind of intermediaries. So, everyone with me, any questions so far? Any doubts? Any queries? Any doubts, guys? Any doubts? Any questions at all? Okay, so let's move forward. Now, as I was saying, in 2008, when the entire financial crisis took place, a lot of people, they started losing that faith and trust within the banking system, because the people who were responsible to keep the money safe, they were the same people and same organizations who were going bankrupt, who were going out of business. And that really started shaking up the trust that people had among the financial systems. In fact, some of the banking organizations, they also lay restrictions on people in regards to the access to their own money. So some banks, they put a restriction saying that in a day a person cannot withdraw more than a certain amount of money. So even though it's my money in my own bank account, I still had a restriction to in regards to how much I can withdraw. And these kind of things, they really made the people think that maybe this traditional system needs disruption. Maybe this traditional system needs to get upgraded. And that is how Bitcoin actually came to the market, and those are some of the issues that Bitcoin started solving. So let's see how Bitcoin actually solved all these issues. Now, to understand this, let's take four major issues that Bitcoin helps to solve. The first issue is of centralized power. Now, when I talk about a centralized power, every monetary system that is out there today is controlled by a central governing authority. It could be a federal body, it could be a unanimous personality, and so on and so forth. Almost all currencies out there today are actually controlled to a certain extent by a central authority. And that is the first problem that Bitcoin came and solved, because Bitcoin is a system which is built on a decentralized and distributed ledger. And this decentralization or distribution is not among certain restricted parties, but it's shared among everyone that is involved within that system. So whoever is a part of the Bitcoin system shares a portion of this power, shares a portion of this authority, and this portion, it keeps getting further distributed as more and more people keep joining the network. So let's say tomorrow you move into the Bitcoin system, then you also would be a part of it, and you would also hold certain power associated with that system. Now, how that happens, that we'll be talking about in a much more detailed session, or in a much more detailed lecture that we'll be conducting. Those are actually those concepts. They are part of the a full-length course that Edureka offers in regards to Bitcoin and blockchain. But for now, just keep in mind that the first thing that Bitcoin solves is the elimination of the centralized power, or the centralized authority that traditional currencies have, because this centralization gets distributed to everyone, whoever is a part of the Bitcoin network. Apart from this, most banking and financial organizations follow a private ledger. The only thing that you are aware of when you put your money into something is whether or not the transaction, a particular transaction that you have made as a person has been executed or no. But you have no idea whether someone else has taken some money, whether the bank has itself invested this money somewhere, and so on and so forth. So you have absolutely no transparency in regards to your money till you actually want to utilize that money. However, with the blockchain system, the ledger in itself is public to everyone who becomes part of that blockchain network, and everyone gets a complete copy of the entire blockchain as soon as they sign on. So there's complete transparency in regards to who are the in regards to the transactions that are happening on the system. So immediately when you sign up for the Bitcoin blockchain, you get a list of complete transactions that has happened from the start of Bitcoin transactions. Now, that's a huge amount of transactions, but blockchain actually makes it very easy as well as completely secure to store all these transaction details. And at the same time, it ensures that none of this gets manipulated. Now, as to how this can be completely secure and how the manipulation is restricted, again, that is a part of the more detailed session that we have. But just remember that in the blockchain system, all the data is not private. In fact, there's a public ledger which keeps track of all transactions that have happened. Now, although it is a public ledger, you can have the complete details with respect to the transaction that happens as part of the network, but you still don't know who exactly is doing this transaction. And this is the anonymity that blockchain gives you. So you can imagine no centralized authority, yet they're keeping the transactions public, and still the personal identity of the users is being kept anonymous. It's a pretty neat thing, right? Exactly. Now, the other challenge that most banks and financial organizations face is the challenge of hacking. Every now and then, we do hear that a financial organization has been hacked and certain data has been leaked, certain transaction details are released, certain amount has been stolen from their accounts, and so on and so forth. So, all this is something that we have heard every now and then. But blockchain system is completely immutable to any of these hacks that can happen in the transaction, or any of these hacks that take place, because blockchain as a system, as a ledger, it cannot be modified. And even if you try to modify the blockchain system, it is built in such a way that it is completely secure, and it smartly finds out if certain alterations have been tried to make on the blockchain system, and accordingly, those kind of alterations, they get rejected, and only the transactions that are legitimate, that are accurate, they will move forward. So we'll be talking about these transactions further as we move forward. But this is another issue that blockchain solves, the issues associated with hacks. Now, coming to the final challenge, which is double spending problem. As I had mentioned, most financial organizations that have a digital platform, they have faced the challenge of double spending in the past. And in blockchain system, double spending is not possible, and this is basically because of how the blockchain system is in itself structured and created. Now, the double spending problem was something that was faced quite popularly at the time when the blockchain system was becoming popular. And keeping this in mind, they had structured the blockchain system in such a way that even in future, the challenge of double spending can be completely tackled without any kind of problem. So so far there has not been, in fact, any transaction that has been double spent on the blockchain system. So those are certain advantages, those are certain problems that the Bitcoin blockchain system solves. Everyone with me so far? Any doubts, any questions, any queries? Any questions, guys? Okay, so let's move forward. Now, the first challenge that we had spoken about was the transaction fees. Now, today there are several different kinds of cryptocurrencies, but most of them they either charge a very minimal transaction fee, or they don't charge any fee at all. So you can transfer your money from one account, which is also called as a wallet within the cryptocurrency world, to another wallet at a very small transaction fee. Uh, if you compare these transaction fees with the traditional transaction fees that are charged within the banking system, they are almost zero. In fact, I had read about a case a couple of years back where someone transferred a few $1 million from one country to another, and the total transaction fee charged in that cryptocurrency transaction was hardly a few cents, not even dollars, but a few cents, and the total amount of time that that transaction took was a few minutes. Now, you can compare how much this kind of a transaction would cost in the traditional banking system, and what kind of fee would that charge. So the blockchain based transaction systems, they're really very efficient. The next thing that we take a look at is how these transactions actually take place within a blockchain based system. So now, before we talk about these transactions, as I had mentioned earlier, for any transaction to take place, a medium is required. And within the blockchain system, that medium is called, within the Bitcoin system, that medium is called blockchain. So blockchain is the underlying technology which makes all these transactions possible. Now, if I were to explain blockchain, the best analogy that I can draw is that of a train. So we all have traveled in a train at some point in time, whether it's in India or in a foreign country. We've all traveled in a train at some point. Now, if you look at blockchain, a blockchain also comprises of compartments, just like a train. And in a train, every compartment is tied to one another. Similarly, in a blockchain, every block is tied to one another. So apart from carrying its own information, a block bears a signature to a previous block, and that is what ties up the entire blockchain in a ledger-like pattern. Now, what that information is that each block contains, how that signature is generated in the block, and how it ties that signature with the previous block, all those things we learn in a much more detailed session. So today we won't be diving into those specifics, but at a high level, every time you think about a blockchain, just imagine a train and consider every block as a compartment of a train. And as the block, as new blocks keep getting added to the blockchain, the chain keeps becoming stronger and stronger, and the information that it contains, it starts becoming more trustworthy. It starts becoming more immutable. So that is what the feature is about blockchain as a technology, which makes Bitcoin so unique. Now, talking about Bitcoin, so Bitcoin was the first digital currency, the first cryptocurrency that came to the market. And it was launched back in 2008. So Bitcoin was released in the form of a white paper that went viral on the internet. And this white paper showed people a way in which they can transact money, or they can transact value without requiring any kind of intermediary to intervene and confirm their transactions. In order to do these things, Bitcoin used advanced cryptography, as well as certain other concepts like consensus and distributed ledger, to make the entire process possible. And all the transactions, they were made electronically, and they were held electronically in a peer-to-peer based open ledger. This ledger was basically called the blockchain. So blockchain is nothing but a record of all the transactions that have taken place right from the genesis block to the final block that has ever been created. And all these things, they happen electronically. So one thing that you should always remember about Bitcoin is that Bitcoin is it's a digital currency, and it can only exist in a digital format. So tomorrow, if someone says that I'm giving you a few Bitcoins in your hand in a physical format, then understand that they are lying. Bitcoins cannot exist in that kind of physical format. They can only exist in a digital format. And lastly, this entire ledger, it is shared with all the participants within the network. And in order to add new blocks to this ledger, or in order to add new transactions to this ledger, each node competes with the other nodes, and this competition is basically executed by solving certain mathematical equations. So as we move forward, we'll see certain aspects of Bitcoin blockchain today. And of course, the more detailed aspects will be covered at a later time and the more detailed lecture. Everyone with me so far? Any questions, any doubts, any queries? Any questions, guys? All right, so let's move forward. Now we will start by understanding how these transactions, they take place within a Bitcoin blockchain network. So for this reason, we will make an assumption that there are 7 people. So we have these 7 people on our screen. We have Kevin, Paul, Robert, Lisa, James, Stephen, and Rahul. So these are the 7 people on the screen, each of whom have certain Bitcoins. And for the purpose of understanding, we will assume that James wants to transfer 500 Bitcoins from his account to Kevin's account. And the miners within the system are Robert and Lisa. So it's these miners who actually help in confirming the transactions, validating the transactions, and ensuring that the transactions are being done correctly. So for our example, we've assumed that Lisa and Robert, they are the 2 miners, and these others are just people who have certain Bitcoins and are looking to transact. And out of that, now, 2 people, James and Kevin, are the ones who are executing a particular transaction over here. So James wants to send 500 Bitcoins to Kevin. Now, when this kind of a transaction has to take place, so let's say this third wallet from the top, that wallet belongs to James, and the fourth wallet from the top belongs to Kevin. So basically, the transaction that needs to take place is that 500 Bitcoins need to move from James's wallet, and they need to go to Kevin's wallet. So that's the transaction that needs to take place. Now, when this kind of transaction happens within the Bitcoin blockchain system, the miners are the ones who need to confirm these transactions. So now, before we go on, let's look at this sample ledger over here. So as we've understood, these are the transactions that are taking place. Now, because James's wallet, it has 1342 Bitcoins. That's why 500 Bitcoins can easily be transferred. So the balance is not an issue over here. That kind of transaction can certainly take place from James's wallet. Now, when these kind of transactions, they get executed, the general process is that James's wallet will initiate a transaction, and when he initiates this transaction, he will have to put in Kevin's wallet address. So a wallet address is the equivalent of a bank account number that we use in the traditional world, and using that wallet address, James will initiate a transaction. Now, this transaction gets propagated to every miner within that network, and every miner individually needs to check that transaction for its validity. Once the miner has checked that transaction, the miner will add the transaction to a block. And once the block has been confirmed, the transaction is then considered confirmed as well. And that is when James's wallet will be debited with 500 bitcoins, and Kevin's wallet will be credited with 500 bitcoins. So that's the overall process over here. Now, in our example, Lisa and Robert are the miners who use their resources to validate the blocks that contain these transactions. So once they have validated the transaction and they have added the transaction to a block, that block, a copy of that block will be shared with every node within that network. So it's not just Lisa or Robert who have a copy of the transaction. Everyone within that network will have a copy of the transaction. So tomorrow, if someone tries to manipulate an old transaction, if someone tries to edit an old transaction, for them to actually be able to execute that kind of maneuver, they will need to make a change to the local ledger or local copy of every node within the network, or they will need to have a majority of power, that is 51% of the power within that network, in order to overpower every other node within that network. Now, not only is this practically impossible, but even if someone were able to do this, there is no benefit that they can gain. There's no advantage that they would get by doing this kind of an activity. And that is where the real power of Bitcoin blockchain comes, that it ensures all transactions are completed and confirmed by every member within the network, or by majority of the members within that network. And by ensuring that the transaction is it's considered a validated transaction, and there is no issue or no problem associated with double spending in these kind of transactions, because every node has a copy of every transaction that has taken place. And before validating a particular transaction, they go through and check for all the transactions associated with that wallet, right from the first block that has ever been mined to the last block that was mined, and they ensure that the transaction is actually a legitimate transaction, and there's no issue of double spending. There's no issue of spending something that you don't have. And by this, blockchain ensures that all transactions are being done in a legitimate fashion. Now, the obvious question that one would ask is that why are Lisa and Robert putting in so much effort and putting in so much resources in order to run these transactions? So the reason why they're putting in all these resources is because for every block that they mine successfully, they get a certain reward. Now, currently that reward is 12 and a half bitcoins. Earlier it was 25 bitcoins. Before that it was 50 bitcoins. So there is always a certain reward associated with the block, and for whichever miner solves that particular block, they get that particular reward as an incentive for running the mining process. And every miner will keep receiving these rewards for mining a block till the total number of bitcoins, which is 21 million, they do not get over. So till all the bitcoins are not created, the miners will continue to receive these block rewards, and it's this incentive that keeps these miners going and continuing to mine regularly. So this is how the transaction within the Bitcoin world takes place. Any questions, guys? So I have a couple of questions here. Suresh has asked that who is called as miner in the real world? Is it government agency or some kind of authority? So Suresh, anyone and everyone can be a miner. That's a beautiful thing about the Bitcoin blockchain. To be a miner, you don't need to be some central authority or a government or a bank. If you want, tomorrow you can download the open source code of Bitcoin blockchain and execute it on your computer and become a miner on that system. So anyone and everyone has the right to be a miner within the Bitcoin blockchain system, and they can start making transactions with the system. They can start confirming the existing transactions, and they can begin to receive the block reward or the incentive for successfully mining a new block. So that is how the blockchain system proceeds. Does that answer your question, Suresh? So Pawan has asked a question that miners should just check addition, subtraction. Pawan, it's not just checking of addition and subtraction, though at a very high level, you are correct. But in the Bitcoin blockchain system, they use a concept of unspent transaction outputs. So we won't be getting into the depths of the unspent transaction output, but yes, you can say that at a high level, they have to check the addition and subtraction of these bitcoins, but they don't have to just check it from the perspective of the last known balance, but they have to actually go back and check for every block where a transaction has been associated with that particular sender's wallet, and make sure that all the credits and debits they match up, and finally at the point of transaction wallet does have the number of bitcoins that it is trying to transfer. So that is how it takes place. Does that answer your question, Pawan? So Vijay has asked a question that how widely Bitcoin is being accepted, since one Bitcoin is over 7 lakh Indian rupees. How do you transact anything less than that? So Vijay, the other thing about Bitcoin is that Bitcoin can be further divided into smaller units. So uh, the smallest unit of a Bitcoin is called as a Satoshi, and one Satoshi is it's 1 millionth of a Bitcoin. So one Bitcoin is made up of a million smaller units, and based on that, you can determine what kind of unit do you want to utilize. So today, if the Bitcoin is worth $10,000, and you want to invest only $1,000, you can always buy point 0.1 Bitcoin. Or if you want to buy only $100 worth of Bitcoins, you can buy 0.01 Bitcoin. Or if you want to buy only $10 worth of Bitcoin, you can buy 0.001 Bitcoin. So in that respect, you can have smaller units. Make sense with it? So Pawan has asked a question that this delays the transaction. So transaction cannot be immediate because miner should accept the transaction. So Pawan, the average time that is required for a Bitcoin blockchain transaction to get executed is considered 10 minutes. For higher confirmation, you can expect that within 30 to 40 minutes, every transaction will be confirmed, because that way you can have multiple confirmations. So on an average, every 10 minutes, a new block is created. And for any transaction to go through, you would hope to get at least 3 to 4 confirmations. Now, that's why that is the time which is required. Of course, in the other blockchains, newer blockchains, this block time is being further reduced. But one thing to remember about the Bitcoin blockchain is that and this is another difference between Bitcoin blockchain and the traditional system. The Bitcoin blockchain doesn't it follows non-repudiation. So what that means is that once a transaction is initiated, it cannot be reversed. It cannot be taken back. A transaction once done will then move forward based on consensus, based on the mining process. So it's not like a banking system where you issue a check and then tomorrow you call up the bank saying that cancel this check or do a stop payment on the check. So you can't do those kind of things on a Bitcoin blockchain system. And because of that, even if it takes a few more minutes for confirmation, it is still regarded as fairly certain as a transaction. And even though it takes 10 or 20 minutes or 30 minutes, it's still much faster than the traditional banking system, which may take 3 to 5 days or even more, depending on the Nostra and Vostra channels that you're using for the transaction. Does that answer your question, Pawan? So Suresh has asked that how many miners need to certify one transaction. So Suresh, on the Bitcoin blockchain system, it's not on per transaction basis, it's on per block basis. So all the transactions, whether it's one transaction, 50 transactions, 5,000 transactions, they all need to be put in a block. And that block needs to be certified, or the block needs to be confirmed by the miners. And the threshold on the Bitcoin blockchain system is 51%. So if 51% of the miners agree that a certain block is created appropriately, then all the transactions within that block will be confirmed. So 51% is the threshold. Make sense, Suresh? Okay. Any other questions, guys? Any other doubts? Any other queries? All right. So let's move forward then. Now we see how the blockchain achieves a Bitcoin solution. So this is a high-level flow diagram. Initially, a transaction is created. Once that transaction is created, that it is called as a transaction request. That transaction is sent to the entire network. So it propagates throughout the peer-to-peer network that we have, and goes to every node within that network. Once the nodes validate the transaction, they add those validated transactions to a block. And once the block is created, the block is then attached to the blockchain, and that is how the transactions, they get confirmed, and the transaction is then considered as a complete transaction. So this is how the high level flow of the entire process takes place. The next is the overview of blockchain. So as we've discussed, blockchain is basically the underlying technology which makes Bitcoin possible. So let's learn a few more concepts around blockchain. Blockchain is basically the addition of new blocks to the entire ledger. And there are three important technologies which make up the blockchain. And these three technologies, they used in almost every blockchain which is out there in the market. So the first technology is private key cryptography. The second one is P2P network. And the third one is a blockchain program. So let's move forward and understand each of these technologies in further detail. Now, the first one is public key cryptography. So before I explain this, there's one point that I want to make, and the point is that every technology that we are going to be discussing now related to blockchain, all these technologies, they have been in existence some time. So blockchain did not come up with any new technology in itself. The key aspect of blockchain was the fact that all these technologies which blockchain is using, they had been put to use together for the first time on a blockchain based platform. So that was the unique aspect of blockchain. That was the key aspect associated with blockchain. And so that's why all these technologies that we'll be talking about, in their own silos, independently, these technologies have been in use for quite some time. So let's start with the first technology, which is private key cryptography. Again, a very old technology. The main purpose of this technology was to send messages on an open network using a secure protocol. So the private key cryptography was basically the secure protocol that people used to use in order to send encrypted messages on an open ledger or an open network, to ensure that only the authorized recipient is able to read that message. Now, for this cryptography concept, they used to generate a key pair, so a private key and a public key. A private key was something which only the owner used to have, or only the authorized signatory used to have, and the public key was something which was available on the network. So if one person wants to send a message to the other person, they would use these keys in order to convert that message into a digital signature. So something like this over here on the right that you see, 6AB, 3D, 9F. So something of that sort, which wouldn't make sense to a naked eye, or which wouldn't make sense unless and until it's decrypted. And the only one person who can decrypt this, or the only key that can decrypt it, is the corresponding private key, whose public key was used to encrypt this message. So that was the entire concept around private key cryptography, and this is one of the concepts that is used in order to initiate new transactions within a blockchain network. The next technology is peer-to-peer network. So basically, the way blockchain works is that every transaction, once it's initiated, it is broadcasted to every other node within the network, and that broadcast takes place by initiating the transaction and pushing it to the nodes nearest to you. So in this case, A finds a transaction, and he pushes the transaction to B and C, which are the nodes closest to them. Now, once B and C receive it, they further propagate the transaction to the other nodes within the network, and that's how the transaction keeps getting pushed forward and eventually reaches all the nodes within that particular network. So the transaction, in fact, propagates very fast throughout the network, because there are no central point of failures or no intermediaries here. Even if for some reason node B is down, through node C, the transaction will further get propagated to all the other nodes. So that kind of a peer-to-peer network ensures that the transactions are propagated really fast within the network. The last concept that we have is a distributed ledger. Now, if you look at the banking system, every banking system relies on a central ledger or a central authority who keeps track of all the transactions. But within the blockchain system, you do not have any such kind of central ledger. In fact, every node in the network has a copy of the same ledger. So there's no central ledger available. In fact, every node has an exact same copy of the ledger. Because of that, even if one of the nodes, let's say Bobby, tries to make edits to his version of the ledger, still every other node in the network has their own version of the ledger available. And because of that, they will easily be able to point out that there's something wrong in Bobby's ledger, and accordingly, that can be corrected. So there's no such central authority which is keeping track of all the ledgers, or which is keeping track of all the transactions. In fact, it's every node within the network who has a copy of that particular ledger. Now, in a P2P network, when you have these ledgers, you basically make use of the digital signature. So the concept of private key, public key cryptography that we saw earlier, it's those keys which are used in order to add new transactions to this ledger. So even though all transactions are being made available to every node in the network, the transactions are secured by these public keys and private keys. So even though people know that the transfer of funds have been made from one public address to another public address, yet the identity of that public address holder is it's not available with the people. And that is another key aspect of blockchain. It ensures that the private personal identity of the individual nodes, or the miners, or the people transacting, it's still kept hidden, even though all transactions are publicly visible, all transactions are completely transparent. So I think there's a question over here. Pavan has asked a question that every person knows the every other person's balance. So Pavan, yes, every person does know the other person's balance, but the people are identified only by their public addresses. So I might know that a particular digital account, that a particular public address has a certain number of bitcoins, but I do not know that that public address actually belongs to Pavan or Suresh or Vijay. that identity is still kept hidden. So even though public addresses can be seen, but the owners of that public address, they are not still available. Does that make sense, Pawan? Any other questions, guys? Any other doubts? Okay, so moving on, the next one is the blockchain program. So now this entire thing is executed within the underlying platform, which is called as the blockchain platform. And on top of it, on top of the blockchain platform, you can write different kinds of programs. Depending on the kind of platform that you're using, different languages are used to write those programs. For instance, on the Ethereum blockchain, you use a language called Solidity in order to write any applications or in order to write any programs. And that is how the blockchain moves forward, basically. So Pawan has asked a question that if I have to send money to X, then I should know his public address. Yes, Pawan. So public address is the equivalent of a bank account number, and if you want to send money to a particular public address, you need to know that person's bank account number for sure. Does that answer your question, Pawan? Any other questions, guys? Any other doubts? Okay, so I think there's one more question. So Pawan has asked, then obviously I can know his balance. So Pawan, yes, if for that particular person, you will be able to see his balance once he gives you his public address. But on the Bitcoin blockchain system, they have this one other option available as well, that you can create new wallets if you want, and you can have as many new wallets as you want. So if you want to keep your balance hidden, then you can always create a new wallet before sharing that particular public address. You can create a new public address, basically. So your balance in your other wallets won't be visible by anyone. But yes, if you're sharing your actual public address, then any Bitcoins in that particular public address will still be visible. So that is basically the concept of pseudo-anonymity, Pawan. So under pseudo-anonymity, what does pseudo-anonymity say is that as long as you want to keep your identity hidden, it will stay hidden. But if you go out and say that this particular public address is mine, then any transactions associated with that public address is also your they are also your transactions, and then everyone knows that okay, you are the one who has made all these transactions. Okay. Any other questions, guys? All right, so let's move forward. Now, the next one is that within the blockchain transactions, so as we've discussed, every participant has a copy of every other transaction within the blockchain system, but all these transactions, they are kept hidden by use of public addresses. So the identity of those people, they are still kept hidden. The identity is still unavailable to the people. But the transactions, they are public and they are all available on the blockchain system. And these transactions, there are three things that help in confirming these transactions. The first is the miners who do all the validation, and they create the blocks. Once the blocks are created, every miner is competing with each other by solving certain mathematical equations in order to add the block to the blockchain. And if there's anyone who tries to corrupt a transaction or corrupt the system, then by consensus, the nodes in the system, they will automatically reject that transaction, and that's how it will ensure complete immutability and complete authenticity of every transaction that has been added to the system. Now, when we talk about blockchain types, there are three main types of blockchains. One is a public blockchain. A public blockchain is the one which is available to to everyone. Anyone and everyone can join that blockchain. They can be a part of the blockchain. They can make transactions on that blockchain, and they can view all the transactions within that blockchain. A private blockchain, as the name suggests, is restricted to only certain parties, only certain restricted parties can view the transactions, only certain restricted parties can be a part of that blockchain. And finally, you have consortiums. So nowadays, a lot of organizations, they have been moving towards creating these consortiums, and the main purpose for these consortium is that they are trying to ensure that multiple organizations are using this technology together. So if you look at blockchain, it's very similar to having an email account. Just because you have an email account doesn't mean it's of any use to you. The email account is useful provided your friends, your family, your colleagues, they're all using emails. Then only you can send and receive emails. But if you alone are using emails, then it's of no use to you. Similarly, the advantage of blockchain comes only if multiple organizations are using it together. But if only you are using blockchain, then there is absolutely no advantage associated with it. So that is where a lot of organizations, they're trying to create these consortiums and groups in order to work collaboratively and create new applications around blockchain. So in a nutshell, if you look at blockchain, you can call it the use of mathematics to create a secure distributed ledger, which actually enables transactions without requiring any kind of third parties, any kind of intermediaries, any middlemen in order to execute those transactions. So that is what blockchain is all about. Make sense, guys? Any other questions? Okay, so let's move forward and take a look at some of the features of blockchain. So the first feature of blockchain is fraud resistance. So as we've discussed, on a blockchain platform, because there's no central authority, there's no single point of failure or no central attack vector. That's why you cannot go and attack a blockchain system, and that keeps it resistant to any kind of fraud. Any transaction that you make on the blockchain system, it will stay secure as long as you ensure that the private key associated with your transaction is with only you and no one else. So that's the only thing required in order to ensure that no one else takes over your transactions. The next thing is consistency. So on a blockchain-based system, you do not need a central authority to validate transactions or keep tab of all the transactions. The entire network, which is using this technology, is the one keeping the technology alive, is the one keeping the network alive, and everyone has the exact same authority or exact same privileges when we are talking about the block. Everyone is an equal, everyone is a peer on the entire network. And finally, you have the incentives. So in order to keep the blockchain platform alive, in order to keep it moving, the way the platform has been designed is that every miner or everyone who's contributing to keep this network alive receives a certain reward, receives a certain advantage and incentive in the form of newly mined bitcoins that are given to them in order for their service when it comes to adding new blocks to the blockchain and thereby confirming the transactions. All right, now we'll take a look at some of the use cases of blockchain. So as I had mentioned earlier as well, blockchain is not something which is only associated with banking and payment. Of course, though, those were some of the initial platforms or initial industries that started using blockchain, but eventually a lot of other industry verticals have started use of blockchain, like the music industry, healthcare, law enforcement, real estate, voting, and a lot of other such industries. So let's take a look at some of the use cases. Now, within the banking industry, it's expected that blockchain could actually help reduce the operational cost by over $20 billion by eliminating a lot of middlemen, by eliminating a lot of third parties that are required to run the banking system. Also, hacking could be reduced and the systems could be made much more efficient. And finally, the issue of double spending can be completely eliminated by leveraging the principles of blockchain within a banking system. And it also reduces any risks and crisis associated with these kind of systems, because there's complete transparency in regards to where the amount is, where the money is, and things like that. Then you have the payment transfer systems. So again, within the blockchain, by use of blockchain technology, firstly, the security of these transactions can be improved. The transaction fee can be reduced significantly, and also you do not need any kind of overheads like bank accounts and intermediaries. You can directly make those kind of transactions using your mobile devices. The next is within the voting industry. So within the voting space, what they're trying to do with blockchain is that instead of you going and waiting in long queues in order to cast a vote and ensure that you have voted for your candidate, instead of following all those procedures, with a blockchain-based system, they can turn voting completely digital. And within that digital system, they can also ensure that there is no foul play through multiple votes or also more than 50% of the miners should accept my transaction. Yes, Pavan. So any transaction that takes place, it needs to be added to a block, and that block can be confirmed only if 51% of the miners accept that transaction. So the value of the transaction doesn't matter. The process stays the same. So Suresh has asked that any idea or reason of value with Bitcoin increase or decrease? Suresh, there are various reasons associated with the change in value. In fact, it's not just change in value of Bitcoin blockchain, but any asset that you take into consideration. There are certain aspects associated with its value, and the first one is supply and demand. So if the supply of a particular asset is less and the demand is increasing, the value is suddenly it starts increasing, and that's true for the Bitcoin blockchain world as well. So initially, the value kept increasing because it was getting more and more popular all over the globe. And then certain countries, they started declaring Bitcoin illegal, or they started putting some blanket bans around Bitcoin, because of which the demand started falling. And for that reason, the value again started decreasing. And now with certain countries coming up with newer regulations and uh, they acknowledging the value of Bitcoin, the value has started seeing some turnaround, some further based on, at the end of the day, supply and demand. Is suddenly some new applications have been developed using Bitcoin blockchain, then further its value can see an increase as well. And tomorrow, if all the governments say that Bitcoin is completely banned, it's illegal, then you'll see a value. You might see a value crash as well. So those are certain aspects associated with the value of Bitcoin. Makes sense, Suresh? So Suresh has asked that I heard number of Bitcoins is constant and will not change. Is it true? Yes, Suresh, absolutely. So the total number of Bitcoins will always be 21 million, and no further Bitcoins can be mined after that. So beyond 21 million, no new Bitcoins can be created. And because of that, the supply of Bitcoins has been made constant. And for that reason, it's all about the demand. If the demand increases, the price may increase. If the demand reduces, the price may reduce. All right. Any other questions, guys? Any other doubts? Cool. So now let's take a look at another blockchain network. This is called Ethereum blockchain network. And when you're using the Ethereum blockchain platform, there are four major steps associated with creating your own version of the Ethereum blockchain. So for now, we'll just be reviewing that those steps at a high level, and in a more detailed session, you will learn further about what these steps are and how they are executed. But the main steps are: first, you need to download the open source Ethereum code, which is available on GitHub. So that is what this first step is all about. You're cloning that particular code to get your own copy of the Ethereum blockchain. And once you get that copy, you can connect to that particular copy and make it available on your local machine. Also, you need to install Golang. So that is the language used in order to make edits to the blockchain platform. So that's why we install the Golang package as well from the internet. The next thing is to create your own Genesis block. So Genesis block is the first block that is ever added to a blockchain, and it's this block that you need to go and create for your own version of the blockchain. Once you have created this block, you're going to put in the rules associated with your blockchain on this particular block. So your Genesis block is the block which where you configure all the rules that are specific to your version of the blockchain, and those are the rules that will be followed going forward as well. What these rules are, what is the meaning of these rules, we'll do in a more detailed session. But just remember, Genesis block is the first block that is added to the blockchain, and that is where you need to put in all the rules associated with it. And once your Genesis block is created, once you have added that Genesis block, the next thing would be to start running your blockchain. So that includes creating new accounts, creating new transactions, validating those transactions, running the mining process, and so on and so forth. So those are the four high-level steps associated with a new transaction. Of course, here we are not going to be going into much detail about those transactions, but in a more detailed session, you will learn more about what these transactions are and how they are executed. So these are the things that we've covered in today's session. We've seen how the banking world works with the blockchain system, without the blockchain system, the history associated with a blockchain, how that solution works, the various concepts around blockchain, and the various use cases. And now we'll take a look at one of the demos associated with a blockchain-based system. So for that demo, let me pull up a tool called Ethereum Solidity Remix. So on this Solidity Remix, I have a code that has been written. This is a smart bank code. Now, this remix is basically an online IDE which is available in order to write codes on Solidity. This entire code has been written on Solidity, and it's a simple code for a smart bank, which allows you to create a new account, enroll a new customer, deposit payments into the account, withdraw money from the account, and so on and so forth. So normally when you're using this kind of code, this kind of code is written in Solidity, the first step is to compile that code. Once the code is compiled, you can run it on three different environments. One is the JavaScript virtual machine, which is a test environment that is available with the IDE. The second is injected Web3, which requires an external wallet to be attached to your IDE. And through that wallet, you can run this code on the actual Ethereum blockchain, or you can run it on various other test networks. And the third is your Web3 provider, which is used when you're bringing up your own a blockchain network and your own ecosystem. So for now, we will run this deployment on this JavaScript VM, which is a local environment here. And you can see these are the different functions that are directly available. You can enroll, so I can hit enroll and get a new enrollment for this smart bank. I can check the balance associated with that particular account. I can deposit money in that account. I can withdraw a certain amount. So those are the various functions that you can learn. Of course, due to the limited amount of time in today's session, we won't be going into more detail associated with how these smart contracts are written and what are the various aspects associated with the smart contract. But in a more detailed session, you will see many more things associated with the smart contract and how they are actually executed, what are these different environments, and how you build up these different environments. So that is what a more detailed session contains. Now, just to give you a high-level overview of Edureka's blockchain course. So Edureka has this course on blockchain and Ethereum certification. It's a newly launched course, and as part of this course, we cover a number of modules which give you a good understanding of the various aspects associated with blockchain. The first module is on the origin and working of blockchain. So in this first module, we'll describe the difference between the traditional systems and this new paradigm called blockchain. We will also get a high-level understanding of the jargon used in the space and the various features about blockchain and cryptocurrency, as well as its advantages and disadvantages. The second module is on cryptocurrency and blockchain. And in this module, we'll talk about the various properties of blockchain, its core components, and the distinction between blockchain and traditional databases. The third module is on the Bitcoin platform, and in this module, we get a better understanding of Bitcoin. As I had mentioned earlier, a lot of people use the terms Bitcoin and blockchain interchangeably. So the main idea of this module is to ensure that people understand the difference between Bitcoin and blockchain, what is the relation between them, and how the two are different. The next module is on Bitcoin mining, and as the name suggests, this talks about the process of mining, which is nothing but creation of new Bitcoins and validation and confirmation of the existing transactions. Then we move on to introducing Ethereum, which is the second largest cryptocurrency by market cap. In this module, we understand how Bitcoin is different from Ethereum, and we review the building blocks of Ethereum blockchain. The next module is it talks about the basics of Solidity, which is the programming language used to write smart contracts on Ethereum. And we have advanced Solidity as well, where we'll be looking at some advanced concepts associated with Solidity, the various inheritance constructors, libraries, and other concepts associated with smart contracts. Post this, you will have a better understanding of this use case as well that we today briefly took a look at. So you'll get a better understanding of all these concepts. The next one is to develop your own DApp using Truffle. Truffle is a tool used to create smart contracts and decentralized applications on Ethereum. So we'll get a better understanding of that. The next module is on Hyperledger, which is it's one of the most widely used networks to deploy decentralized applications for enterprise purposes. And we'll understand the basics of that, as well as review a tool called Composer, which is used to create enterprise applications using Hyperledger. The next one is to review multi-chain. Multi-chain is another off-the-shelf platform used to create blockchain applications for enterprises. And finally, we'll be taking a look at some of the prospects of blockchain, some of the applications and use cases which are commonly used in the market. So those are the various things associated with blockchain that the detailed course has. You all are welcome to review the course through the website, and if you'll need further help, Edureka's help desk is always available to answer your questions. And with that, we come to an end of today's session. I hope this session was useful, and I hope you all have some takeaways with this session. Of course, it was a brief session where we just touched on some of the key aspects and features associated with blockchain. But if you all have any questions, any queries, I'm more than happy to answer it. Let me know if there are any questions. Any questions, guys? Any questions? Any doubts? So Suresh has asked that is this material available for us to view later? Suresh, you'll have to check in with Edureka on that. I'm not 100% certain as to how they handle the material aspect, whether it will be made available to you, or whether this section will be, its recording will be made available. So that you'll have to check in with Edureka, and they will be the right ones to answer it. Any other questions, guys?